Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary STROOPE Family Foundation, Panama-BUENA VISTA Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marylou.
And in studio with us today we have Areen. And Areen, if somebody needed to get a hold of us, what would they need to do?
For math homework help, call 636-4357. Toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. How are you today?
I'm good. How about you?
I'm doing well myself. Why don't you let everybody know where you go to school and what grade you're in?
I go to Reagan Elementary School, and I'm in 6th grade.
You're a patriot.
Yep.
Have you been a patriot for a long time?
Yep, since kindergarten.
Since kindergarten?
Mm-hmm.
All right. Obviously, your 6th grade year is a little different.
Yes.
What is the biggest thing that you see as, that you could, like, you know that everybody's doing virtual learning, right? If there's one thing you could do to make virtual learning better, can you think of anything that might make it better?
Better internet connection.
Better, yeah, there you go. You know what? Because I know a lot of times people get dropped out and things like that. They get kicked out of a meeting and things like that. So it'd probably run a little smoother if we had nice connections to go along with everything, right?
Yeah.
All right. Now, you're working on exponents, and this is a little something extra from your regular classroom, right?
Yes.
What are you working on in your regular classroom right now? Do you know what?
Yeah, so we're doing conversion of like rates. So we're converting like 6 cups to quarts and stuff.
So you're doing measurement.
Yes.
So measurement and conversion. All right, good. So you know what? We might take a look at some of that later on, but we'll definitely take a look at some exponents as well. You good for that?
Yep.
All right. We have a visit from our friends from Science for Kern also today. But first, before we get to all of that fun stuff, let's first take a look at today's Math in the News. And today's Math in the News, we are once again fortunate enough to have an actual visitor in studio with us today. And we have Brian Miller. How are you today?
I'm great, Mike. How are you?
I'm wonderful. You are a principal with the Kern High School District, but there's something a little different about your position. You want to explain that a little bit?
Sure. So I get the pleasure to be the principal at 2 sites, the ROC and our brand new school, CTEC. And they're both amazing facilities with amazing opportunities for students to pursue a wide variety of career paths.
Now, I know a lot of students are probably familiar with the ROC, and that's been around for a long time. But the new one, CTEC, what's up with that?
Yeah, so we just opened our doors in August, and it is a state-of-the-art facility for career technical education. There really is nothing like it around. It's a 2-story building, and we have 17 different pathway opportunities in there. It's designed to be an innovative space for learning, and I think we really pulled that off. So we can't wait to get students in there soon. We're doing distance learning like everyone else right now, but in the near future, we hope to get kids back in there and get to experience all the cool things that we have to offer in there.
Now, I mean, that looks awesome. The brand new facility and everything like that, of course, is going to look awesome. But that is exactly what you want, for students to get hands-on and learn about the field to see if that's what they actually want to get into.
Yeah, and I think that's the great thing about all the educational programs at the ROC and CTEC is Students really get a chance to dive in and get their hands dirty in the educational process and experience what it's like to work in that field.
Now, you said there were 17 different pathways for students to take. Are there some that are more popular than others?
Yeah, I mean, almost every single program is impacted, which means that they carry a waiting list of students. You know, but at CTEC, some of our ones that are more impacted, that's where all of our healthcare programs are. We have a lot of students that want to go and work in the healthcare career and all the different career paths that we have to offer there. So that's definitely one that is very impacted. We also have some of our technology programs have become really impacted, like 3D animation and video game design. You know, kids want to learn about those career paths and kind of get started on that. So yeah, we've got a lot of exciting opportunities there. Our law enforcement program's a great one there. Our robotics lab is amazing there. Some of the technology that the kids get to get their hands on is pretty awesome.
Well, it certainly is a beautiful building, and this is on the second floor?
So that's in our warehousing class. So we have a
now,
logistics, logistics program there, and that's the front of the school there. Yeah.
Okay. Now, is this open to all Kern County high school students?
So all students in the Kern High School District who are in their junior year or senior year are eligible to come there. So that's about 23 schools that feed into us. We also offer some programs in the evenings for adults, and in the summers we do junior high summer camps as well. So there's opportunities for everyone at both campuses.
Oh, good. So as you said, you're doing some virtual learning right now.
We are.
As everybody is. And you guys are starting to phase some students in, right? So you've got some students back in November?
Yeah, so we're bringing some students back on November 9th, and we hope to do that and then kind of start with that group and then expand from there.
All right, great.
Yeah.
Well, you know what? We certainly do appreciate you coming, taking down some time, talking to us a little bit about the CTEC as well as the ROC program. Beautiful building that you've got out there. Where is that?
So it's right next to, just north of Independence High School on Old River and Berkshire. Berkshire.
Oh, well, you know what? If you're in that part of Bakersfield, you can go out and check that out, and who knows, might stop in sometime, say hi to Brian, and take a look around the place.
Be great.
All right, that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We've got Areen. Areen is a 6th grade Reagan Elementary student, and Areen is working on exponents. So Areen, if you wouldn't mind, head on over to the board, you and Marylou. And first of all, what I would like you ladies to do is first of all just talk a little bit about exponents. So Areen, if you can kind of tell us what you know about exponents, and then we'll go from there.
All right.
So what do you know about exponents?
So exponents are like when you have a number but you want it to multiply by itself any number of times you want. So say you want 2 to multiply by itself 2. So 2 times 2, you can also write that as 2 to the 2nd power, or 2
Can you show
squared.
us what that looks like?
Yeah. So 2 times 2 can be 2 to the 2nd power, or 2 squared.
Okay, so what does that equal?
That equals 4.
Okay, so if I have a problem, if I'm doing exponents, okay, and I have 3 squared, because the 2, it's 3 to the 2nd power, correct?
Mm-hmm.
But we say, with 2's, we say squared. If I give the product of 6, am I correct or not?
No.
What did I do incorrectly?
You did 3 times 2. And
Well, it says 3 and 2.
with an exponent, it means 3 times 3. So 3, it means the number multiplied by itself.
Okay, that many times.
Yes.
Okay, and that is a real common error of students, is simply that. And so what would my correct answer be then?
9.
Can you give us another example of exponents?
Okay. 4 to the 3rd power. That is 4 times 4 times 4. That is 64.
Did you do that in your head?
Yes.
Very good. So what were you thinking to get to 64?
when I was younger, I memorized times tables, so it was just 4 times 4 is 16. 16 times 4 is 64.
Very good. Anything else with exponents? Because this is mainly the basics of exponents, right?
Mm-hmm.
Have you learned anything in addition to the basics?
Yeah, so I can do like tables with exponents. So like finding the number. So you have 3 to the second and 3 to the third and 3 to the fourth. I can find the answer like this and then continue the table. One of my
Okay.
yeah.
Okay, so let's see what that looks like.
6.
Oh.
Sorry.
I tricked you there, didn't I?
Yeah.
Oh, there you go.
You know what, if you want to, it might be easier just to make the table bigger.
Bigger. So
Yeah.
let's
Maybe just
do
erase the whole
this.
thing and make the table
Yeah.
bigger. That'll be easier to write in. Make it as big as you want. There you go.
Okay, 3 to the second is 9, and
And then
that can be continued as 3 to the third, and then
now, with doing that, okay, what are you thinking to get to 27?
I'm doing 3 times 3 is 9, so 9 times 3 is 27.
Okay.
3 to the fourth. And then okay,
And just touch anywhere on the board. It'll go away. There. Let's do this. There we go. Just touch off to the side. It should be. There you go. You'll be okay.
all right. And that's 68. And that can be also written as, or it can continue as 3 to the fifth.
Okay, so you're writing in exponent form, right?
Mm-hmm.
And when over there, when you did the 4 to the third, the 4 times 4 times 4, that's standard form, correct?
Yes.
Okay, so I'm going to give you a little problem here, okay? What if I gave you b to the fifth?
Now, hold on a second. I want
Okay.
to make sure we're all cool here with this 3 to the fourth.
Is that,
So you had 3 squared. 3 times 3 is 9.
Mm-hmm.
9 times 3 is 27.
Right.
Now 27 times 3, we're going to do that again, right?
Right.
right.
But it looked like you may have written 27 times 4 down below, which is how you got an 8.
Ah,
You see what I'm
good
saying?
eye. So let's look at this again. 7 times 3 is?
21.
Okay,
so
I'll let you correct that. Go ahead.
All right. It's a 1, it's a 2. Oh, okay. It's an 81.
There we go.
And another quick way to get to 81, if we look here, we have our 3 times the 3 times the 3 times the 3.
Mm-hmm.
I know that that's 9. I know that's 9. And 9 times 9 is
81.
81.
There you go. Nicely done. So that's just some basics on exponents right now, right?
Right.
Nicely done. You've done some good work right there. We'll continue with exponents in a little while. What you can do is erase the board for me because, Mary Lou, we've got a problem right now for you from Araya, a student at Old River Elementary. How are you, Araya?
I'm good.
Good. As soon as you're ready, let's hear the math problem that you're working on.
Okay,
Okay.
here, I'll go ahead and get that. Okay, go ahead.
If 1 order of fries and 5 burgers cost twice as much as 3 orders of fries and 2 burgers, how many times as much does a burger cost compared to 1 order of fries?
All right, an excellent problem, and I'm so glad you called in with this one because I know there are a lot of students working on this. And you don't need to remember it all. I've got it up on the screen for you right there.
Okay,
Okay.
so-
Now, does this sound familiar to you?
Yes.
So,
Okay.
Areen has had to do this for homework, I do believe this week, correct?
Yeah.
Would you like to help me on this problem?
Sure.
So
Okay.
both of you are going to work on this together. All right. The problem is up on the board so you guys can see it together. All
Okay.
right.
You
And
tell-
then Araya, what I want from you is how would you start this? I mean, do you have any idea even how to start it or anything to write to make it a little bit
Not
easier?
really.
Okay. Well, you've got Marylou and Areen to help you out with this.
Okay, how did you start this problem?
So I kind of made an equation. So like, F, which is fries, equals 5B. Oh, I'm doing this.
Twice? Okay.
No. It's plus. So
Okay.
1 order of fries plus 5 burgers.
Equals, it says twice as much as 3 orders of fries.
Equals 2 times 3F plus
And 2 burgers.
2B. I said this was pretty much the equation that I
Okay,
started with.
and close out.
All right, so let's stop right there. Araya, what I need to know from you is, do you understand what's going on the board right now?
Yes.
Okay, so explain to me what Areen has written up there, so that way I can make sure you understand it as well. So what does the F stand for?
Fries
Okay, and what about the next part, 5B?
is for 5 burgers.
Perfect. So we see that the order of fries and 5 burgers is going to be equal to twice as much as all of the other stuff. All right?
Okay. All right. So, again, I want to point some things out, especially key words. I'm looking at that word problem, and it's simply write it as you read it. And I
Right.
love the way that you brought in the variables, and you looked at that word and you were like, oh, that's going to be a plus, right? And then you saw the equals, or it says, and 5 burgers cost twice as much. So we know that this first part here is going to equal the second part, okay? So breaking this, once you now have your equation, how are you going to break that equation down?
I'm going to do distributive property over here.
Perfect.
So we get 6 fries plus 4 burgers equals 5 burgers and plus 1 order of fries.
So I assume now the next step is to simply,
So Araya, do you understand what happened with the parentheses there?
Yes.
Okay.
So,
she simply, Araya, remember we did distributive property, and we can multiply with unlike variables. You can't add unlike variables, but you can multiply. And that's with the distributive property, and that's what she did here. Okay?
and Marylou, we're going to be put in a perfect situation right now. You are going to be as quiet as I am right now. Araya, you're going to explain to Areen what to write next. So do you have an idea what to do next? And if not, Areen, you help Araya. And Areen, if you need help, then you can ask Marylou. But otherwise, it's the Areen and Araya show right now. So have you got an idea, Araya?
Not really.
All right, Areen, you've got to help her out if you can.
All right, so we're going to combine like variables. So you can subtract the F here and subtract an F here. And we get 5F plus 4B equals 5B. Yikes.
So Araya, can you explain what just happened there? Okay, so Areen and Marylou kind of go through what
Okay.
just happened.
So what we need to do is when we have an equation, we have to make sure it balances, okay? You know, think of your balance scale. Well, what we want to do is we want to combine all the variables, the same variables, which we call like terms. And we see that we have f's on both sides, right? We have an f here, and we have 6f over here. In order to combine them, I'm going to have to kind of adjust it. So I'm going to take an f off, one f. I'm going to take that off on the left side, and then we're going to take it off on the right side as well. So think of like money. We got to take the same weight off. So we're taking the same weight off. And now, once we subtracted that f, now we're looking at the other variable, which is b. So, right, what do you think we want to do? We have a 5b here, and then we have equals 5f plus 4b. We can't really take that 5b away, go subtract 5b, subtract 5b. So what do you think we should do? What should we subtract from our equation next?
We should subtract the 6 minus 5 so we can get the b by itself.
We need, well, we want to get rid of, what would you get rid of here?
I would take away the 4b on both sides.
Very good. Do you see we have the b on both sides? So yeah, let's take away, go ahead and do that. Let's take away the b's. Because we want to get the f by itself, not the b. We want to kind of get that f by itself.
Right, and this can also be written as just b.
So now we know that the b, and what does the b stand for again?
Burger.
The burger. So how many burgers does that mean? That means one burger. One burger is going to be equivalent to
5 fries.
5 fries.
So let's take a look at the question one more
What
time.
is the question asking though?
It says, how many times as much does a burger cost compared to one order of fries?
So what do we need to do now? Are we done?
No.
We're not done yet. We know that one burger costs 5 fries, but that's not what it's asking.
Right.
Okay, continue on. What do we need to do next? And if you need to move it, let's go ahead and
Okay.
right here. We'll move it down for you. There you go.
Right, so since they're asking how many fries, so what's the comparison between a burger and one fry?
Yep.
So it's 5b equals 1 fry, because since there are 5 fries for every one burger. Wait, nope, this is wrong.
We want to know, again, it's the cost, how many times as much does a burger cost compared to one order of fries?
And you can just
So can we,
reason through that right
Yeah.
now. Right.
Right. So for every one order of fries, there is a 1/5 of a burger.
yes. And what you can also do is this. We want to get the fries by itself.
Right.
So can I divide 5 by, and we know we had 1 there, right?
Right.
Which cancels that out, giving us
1/5 b equals 1 order of fries.
equals 1 fry.
Right.
All right.
There you go.
Nicely done.
That's a great
Well, Araya, for
question.
calling in with that problem today. You've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. We do have phone tutors available until 5:30 this afternoon. The phone numbers are at the bottom of your
where is
screen.
it?
Periodically throughout the program, we'll be back with more right after this. Today we're in Bakersfield at the Bakersfield Jet Center by Lloyd's Aviation. And right with us today we've got Steve Lloyd.
Hi,
And what is your official title with Bakersfield Jet Center?
I'm the president.
So
Yeah.
we've got the top guy with us. then, right?
Today you do, yep.
All right.
But we got a lot of qualified pilots around here that can do the same thing that I'm going to talk about today.
Well, let me ask you this: how many pilots do you have employed?
Primarily, we have 2 full-time guys besides myself, and then as needed pilots.
Okay.
Yeah.
Now behind us, we've got a beautiful airplane.
Yes.
Give us a little bit of information about
Sure,
this.
sure. We'll give you just kind of a quick tour. This is the Cessna Citation XLS, and this is what's considered to be a mid-size corporate jet. And this carries up to 8 passengers and flies as high as 43,000 feet at a speed of right around 500 miles per hour. It has a range of about 1,700 nautical miles, which turns into about 1,900 statute miles or so.
Okay, so there's a little bit of math in between there
There's math
also.
right there. So you can ask your students, what's the difference between a nautical mile and a statute mile? Well, basically, it's about a nautical mile is about 15% more in distance. 5,280 for a statute mile and 6,000 and something.
A little more.
They can get their calculator and figure it out. But
Okay.
in aviation, as in the marine world, we're talking nautical miles. And everything is nautical miles speed, and that. Now, when it comes to elevation above the ground, we're talking feet, not meters.
Now I know that there's an alphabet that goes with aviation.
Mm-hmm.
Okay, so like M would be Mike, and
Right.
November, things like that.
It's just a way to be able to identify the alphabet in a way that is constant and everybody understands it. Like this airplane, the call sign on this airplane is N362CA. So when we call on the radio, it's 362 Charlie Alpha.
Let me ask you this, because a lot of students may ask, all right, we understand the Charlie and the Alpha, but what about the N? Because that's at the beginning of all of these airplanes, right?
That's the beginning of all the U.S. registered airplanes.
Okay, so there's the
Okay?
difference right there. So
Right.
why?
Each country's registration, or we call it N number in this country, it starts with a different number. N for the United States, there's either numbers or letters that follow that.
Okay.
This is a Pratt & Whitney 545W. It produces 4,100 pounds of thrust.
And again, a big thanks to Lloyd's Aviation. A lot of math and science going on out there at the airstrip. We do have phone tutors available until 5:30 today, but right now we have time for our friends from Science for Kern. All right, in studio with us, Michelle. How are you today?
I'm great, Mike. It's good to be here.
Nice to see you again. I certainly do appreciate you guys coming down and visiting us here in the studio every once in a while. Usually you're out and about in schools, but this is the next best thing.
Today I have Areen, and that's just as good as being out in the classroom. So today we have another activity from the Science for Kern program that we've actually shifted to a distance learning format. Typically, teachers check out a Science for Kern unit, and they get our materials organized into a cooperative group packages. But instead, teachers can now request the Science for Kern program, and we pack up our materials in individual bags for the students to do science at home. And today I have, so if the teachers check it out, the students are each going to get their own bag of supplies. And today's activity is actually called the sled pull. And it comes from the scientific method unit, which a lot of teachers use it to prepare their students to do a science fair project. So, are you ready, Areen?
Yep.
All right, awesome. So today we have some very simple equipment as part of our project today. We have some pennies. We have a couple of weights, actually a couple of nuts, but we're going to use them as our weights today, a small one and a large one. And then we have what we call our sled. And so we have a little placemat here to help us remember how to set up our experiment. So we take our container here, and we're going to put our little cup over the side. And first, what we're going to do is see how many pennies it takes to move the sled
Okay.
across the track.
All
All right, so I'm going to tell you right now, I have 20 pennies here on the table. How many pennies do you think it will take to load the cup with to get the sled to move down the track and touch the straw out of the 20?
13.
13. All right, are you ready? Let's try. Start grabbing pennies and loading them in the cup one at a time. 1, 2, 3, 4, 5, 6, 7. Well, that's all right. That's what we wanted to have happen. Right, so it moved, right? At 7. Awesome. So let's make note of that. Let's put a 7 there. While you do that, I'll reload. All right. So let's try it again. And let's see if we get 7 again. So go ahead and start loading pennies in the cup one at a time. 1, 2, 3. That's all right. You can get another one. 4, 5, 6, 7. There we go. All right. So go ahead and record your number there. All right. And let's try it. So let's try one more time and let's see what we get this time. Because in science, we never do just one trial. We have to confirm our findings. So 1, 2, oh!
Whoa.
Oh, whoa. So what do you think happened differently that time?
The pennies or maybe I put the pennies in too fast.
Oh, okay. Maybe that does make a difference. So make a note there that our third trial was 2 pennies. Now, based on your findings so far, we're going to put this weight in there. You want to touch it? All right. Put it in. Now, before we do anything, how many pennies, based on your trials so far, how many pennies do you think it will take to move the sled this time? It took about 7 empty. So how many do you think it will take to move it?
15.
15? All right, let's test. Ready? Let's load those pennies in. 1, 2, 3, 4, 5. Oh, all right, make note, and I'll reload. 5. All right, let's do it one more time.
Over.
All right. Here we go. 1, 2, 3, 4. Keep going. 5. Oh my goodness. 6. Oh, there we go. All right. Make note of that. All right, let's do, so that we don't run out of time, let's this time try the largest weight.
Okay.
So, you want to test? What do you think?
Okay.
What do you think that time?
Well, these were less than this one, so maybe
Wanna
5.
compare?
Five.
Okay, so 5. Why do you think 5 this time?
Well, because the box with the small weight, so I was going big numbers on both of these, but they ended up being smaller. So the box with the small weight was less than the box with no added weight. So I'm thinking maybe the box with the larger weight will also follow that same pattern.
Okay, all right. So let's put the big one in there, and I'll take the little one from you. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
One fell out.
That's okay. That's okay. Keep going. 15, 16. Oops, that was 17. 18. I don't want to move it. Oh, look at that.
18.
18. Wow, are you surprised?
Yes.
So, what is our science word for what caused the weight to move down the track? What do we call that?
That's called force.
That's called force. And what is your thinking around what that word force means?
It means the pressure applied to get a certain thing to move a certain way or react.
That's awesome. And when we apply a certain amount of force, we do work. That's excellent. Too bad we couldn't invent one of these contraptions for to clean our bedrooms up, right?
I know, right?
All right, well, thank you.
All right, nicely done. Thank you, Michelle, for that. And as you said, if any teachers would like to check these out,
Yes.
they get individual bags for the students to use, and that could be one of the activities that they could have students use.
Exactly, yes. If teachers are interested in doing this activity with their students, they would check out the scientific method unit, and they'll actually get this hands-on activity, and there's a second one in there as well, where the students get all the equipment they need to do the science at home individually, and then the students get to keep the materials and replicate the activities with their families.
There you go, even better. And keep the 20 cents too? You send 20 cents to them?
Yes, they do.
There you go. All right, science for Kern.org.
Science for
Right, there you go.
Kern.org.
So that is the website. So thank you once again, Michelle, for coming down, and thank you, Areen, for helping out on that. We'll be back with more right after this.
Hi, my name's Buffalo. Today we're going to explore some wetlands here in Morro Bay.
A wetland? What's a wetland?
What does it sound like?
Land that's wet.
That's pretty good.
A land that's
pretty
wet.
good.
Oh, look, I found some right over here. Right over here. There's some wet land right here. Hey, we found a wetland. It's right there.
No, that's a puddle. That'll dry up in a couple of days. A wetland is someplace that's wet most of the time.
Oh, wait. Oh, wait. I think I found a place over here. Oh, look, I found a wetland. Look, it's really wet right over there. That's a wetland.
Yeah, but that's a little too wet, and there's no land. Lakes and rivers and ponds have water in them, just like this bay here, but they're not wetlands unless there is some sort of land around them. There are three things that you have to have in order to have a wetland. You have to have a place that's covered by water most of the time. There's going to be soggy soil most of the time, and there's special types of adaptations that plants have that allow them to live in that particular area. Let's go look at one instead of just talking about it. Well, here we are, our first wetland, the salt marsh.
Huh. Doesn't look very wet to me.
Well, let's get a little bit closer.
Wow, I see what you mean. It looks pretty swampy out here.
Actually, the correct way to describe it would be marshy. Swamps have trees and bushes. Do you see any trees or bushes around here?
No, just looks like a bunch of small plants.
If it's only small plants and grasses, then it's considered a marsh. Let's take a closer look. Now, these plants are specially adapted to live in a salty environment because several times a month, they're completely covered with salt water. In science, we call these plants halophytes.
So they're covered with salt water? When does that happen?
Usually during high tide, and depending on how high the tide is, determines how much of the marsh gets covered.
Oh, so if we were here at high tide, all these plants would be covered by water? Huh, we must be here at low tide.
That's a great observation.
Hey, when I go to the rocky shore and the tide goes out at low tide, we get to see tide pools. Are there any tide pools here by the salt marsh?
There's no tide pools by the salt marsh, but there is another habitat that we're going to go and look at next. Now, we've come to the edge of the salt marsh. You can see where it ends right here. But just on the other side, a whole new habitat starts. It's called the mudflats.
The mud flaps? That's a weird name. It doesn't look like a mud flap to me.
Not mud flaps, mud flats. They are covered with water every day for up to 6 hours at a time. That's why no plants grow out here.
Hey, look, it's Kat from Keep Ocean.
Yeah, she's going to help us explore the mudflats.
What's to explore? It just looks like a big, flat, muddy area. Looks kind of boring.
Do those birds look bored?
No. Looks like they might be eating or something. I don't know.
There's all sorts of little animals hidden underneath the mudflats. And those birds have special beaks and toes that are sensitive to the little tiny movements. They're able to actually find those animals hiding under the mud, even though they can't see them.
Oh, so there's animals under the mud. Hey, can we go find some too? Let's dig some up.
Ooh, let's talk about that. So when we go exploring the mudflats, we have to do it like scientists. This is a protected area, so we actually have to have a permit. I brought ours with us that we have from the Department of Fish and Wildlife. I even sent them an email to let them know that we were going to be here today. I also brought all sorts of cool science tools with me. I had this cool tube that we call a slurp gun. If you've ever seen a potato gun before, it's kind of the same idea, where I can suck up the mud and it's going to then let me spit it out. I can dig a lot faster that way. And then when I find cool animals, I'm going to be putting them in these display tubs so that we can see them. Now, the best thing when we're at the mudflats to find animals is to find holes that look like volcanoes. Come here, I want to show you. So this is a great example right here of a pile of mud on the outside of the tunnel. And that way you can tell that an animal's been in there recently. All of these holes are actually connected to each other in different ways. There's a whole world underneath here, and we're gonna see if we can find some animals that live here. A bunch of cool animals. The first ones I'm going to talk about are these worms. Now, the worms that live in the mud have special adaptations that are different from the worms that live where you might find in your garden. So these worms are called polychaete worms because they have little tiny hairs. And those little tiny hairs on the edges of their body help them to move more easily in the mud. And what's really cool is these worms can be carnivores. They will actually shoot their mouth parts out of their mouth, kind of like if you've ever seen a video of a chameleon. They can shoot their tongues out too, and that's one of the way that they can grab their prey. So there's one really cool worm in here that's kind of hiding called a scale worm. And not only does it have little hairs on the side, but it even has little protective scales on the back of its body, and that gives it just an extra layer of protection. What else do we have, Buffalo?
In this container here, we have shore crabs that actually burrow down into the mud. Now, these crabs come in two different genders, both male and female. And I can show you the difference between the two if you like.
Okay.
This is a male shore crab. Can you see the little triangular shape appendage right there? That used to be a tail. Now it's tucked under it because they don't use it anymore because they're not swimmers now. This is a female shore crab. And you see, she's got sort of a horseshoe-shaped tail, and she actually carries her eggs underneath that when she's getting ready to have babies.
All right, so we saved my favorite mudflat animal for last. Come on in, check this guy out. This is a ghost shrimp. And if you look, it kind of reminds you of a shrimp because of that pink color. But if you get a chance to look at its tail, it might remind you of another animal. This is actually a species of lobster. Now, these guys are awesome. They have all these different appendages that they're using, an antenna in the front. Ghost shrimp are kind of like the Swiss Army knife of crustaceans. They've got 2 legs for feeding, 2 for cleaning, and 2 for digging. They are really good at making a lot of those holes that all these animals in the mudflats can live in. And that's why they're one of my favorite specimens to see. So that's just a small sampling of all the cool animals that live out here in the mudflats. Thanks for joining us.
And thank you for joining us on our trip to the mudflats here at Morro Bay.
Well, I'll tell you, the mudflats are fun, as well as all of the other different activities they have over at Camp Keep. We do have phone tutors available here until 5:30 this afternoon. We've got Areen, a 6th grade student from Reagan Elementary, and Areen has been a Patriot since kindergarten.
Right.
What are you going to be next year, do you know? Do you know what school you're going to?
Probably Warren.
Are they Wildcats or something, maybe?
I think so.
I'm guessing.
I think so.
Warren Wildcats, right? All right. Have you ever read the comics in the newspaper or magazine or online or anything like that?
Yeah.
Well, we've got a comic right here. All right? Let's take a look at it together. So the daughter says, "Dad, how do you find a square root?" The dad says, "First of all, don't even bother looking, because trees are round, hence there is no such thing, silly." The child responds, "You know, you're scarring me for life, right?" So, do you see the humor in that?
Yes.
Okay, can you kind of explain it a little bit? Why is that funny to some people?
Well, because the dad is totally misunderstanding what she's trying to say. She's trying to find the mathematical square root, but he's talking about actual tree roots.
There you go. So what is a mathematical square root? Do you know?
Yes.
Because you were just working with square numbers and exponents. So what's a square root? Can you kind of give us an example? I mean, if you want to write it up on the board, you and Marylou talk a little bit about square root.
Right, so a square root is like the square root of it's not like that. It's
You're close.
Yep.
yeah, it's like
You're
a
very
V,
close.
It's a V shape almost.
There you go. Perfect.
There you
No, it looks like a division sign, right? But it just has that little extra tail to it.
Mm-hmm.
So what is the square root of 64?
8.
So my question is, how is this similar to doing to what exponents, what we were doing?
Well, in this case, 8 to the 8th power, 8 to the,
Squared?
yeah, 8 squared would have been 64.
Right, so 8 squared doing our exponents, let's see, where am I? Oh, 8 squared, we know equals 64, right? Because it's, again, 8 multiplied by 8. But the square root is the backwards of it, right? We're working backwards. The square root, and this is called a perfect square root, right? Because it comes out to a whole number, right?
Yeah.
It is equivalent to 8. But there are numbers that are not perfect square roots.
Right.
And
And that's fine for now. I
Okay.
just wanted a brief
just go
introduction
there.
so that you know the
There we
difference
go.
between a square root, square numbers, and things like that. All right, so go ahead and you can erase the board right there, and we'll get ready for our fun little activity of the afternoon. So, Areen, are you familiar with nursery rhymes?
Yes.
Can you think of one offhand? Yeah, I mean, you don't have to recite the whole thing, but do you remember the names of any of them or what they were about?
There was one about a duck, right?
About a duck?
Yeah.
It could be. The ugly duckling, maybe?
Oh, yeah.
Yeah.
All right, well, there's one right there. All right, so I've got a beautiful one for you right here. Have you ever heard of St. Ives?
No.
No. Oh, this is a beautiful one right here for you, okay? So, as I was going to St. Ives, all right, and we're talking about this guy right here, all right? So he's going to St. Ives. As I was going to St. Ives, I met a man with 7 wives. The 7 wives had 7 sacks. The 7 sacks had 7 cats. The 7 cats had 7 kits. Kits, cats, sacks, and wives. How many were going to St. Ives? So, you've got a guy, right? And he has 7 wives. Okay?
Right.
Now, the 7 wives, each wife had 7 sacks. And each of the 7 sacks had 7 cats. And each of the 7 cats had 7 kittens.
Okay.
Okay? So we're talking about kits, kittens, cats, sacks, and wives. They want to know how many are going to St. Ives. So how do you think you would figure out this problem?
Well, I'm pretty sure there's a way to do it logically, but what I see is like you can do 7 times 7, which is 49, so you get 49 kittens going to St. Ives.
Okay, why don't you write this out for us?
Okay, so 7 times 7 equals 49. So 49 kits.
So
you're going backwards?
First, yeah, you're starting backwards.
Right.
Let's start at the top, okay?
Okay.
So this is the trick right there.
Right.
First off, we have a man.
And I may not erase like that.
Yeah, okay, let me, right here.
Oh, there you go.
There you go.
So first off, we see that there's a man. That man equals equivalent to 1, correct?
Right.
By himself. And he had 7 wives, okay? So we know that we have here, and you could probably write on there, we have the 1 plus the 7, right? Okay, so write that on the paper right next to it. So we have the 1 plus the 7. Okay, now the next line says the 7 wives had 7 sacks.
So
Now, did each wife have, so there was just a total of 7 sacks, right?
For each wife.
Oh, 7 sacks for each wife.
the 7 wives, yeah, so it would be 49 sacks.
Okay.
Right.
Right.
So you can put that off
So
on the
let's
side
put
if you
that
want.
off
So
to the
there's your
side, 49. So we have the 8 people going, right? And then we have the 49 with the sacks. And then 7 sacks had 7 cats.
Now, here's one other way that you can start writing this and keep yourself organized, all right? Over on the side, right, we had 1, right? Now, underneath it, how many wives?
7.
Okay, now underneath that, how many sacks?
7.
No. How
49.
many what did we come up to?
49.
Okay.
And how can we write that using exponents?
So I want you to think, what was the chart that you were showing me? Could this be that chart? Remember at the beginning of the show you were showing me that chart?
Yes.
Okay. So if we're doing that, how can I write 7 as an exponent?
7.
So 7 would just be
It's
7.
just 7
right?
to the or 7 to the first power, right?
Right.
7 to the first
So
power.
now we have 7.
Now for 49, we're writing 7 to the
7 to the 7th power.
or 7 to the second, because 7 times 7 is 49, right?
Yeah.
So now,
No, you know what? Keep going.
keep going.
Keep going.
So what do you think? See, what are you thinking about that? Right there, 7 to the first power, 7 to the second power.
It's going to go 7 to the third
Do you think we could try 7 to the third power and see if there's a pattern there?
Okay.
All right. Let's go 7 to the third power.
7
And what is that covering?
That is covering the sacks and the cats.
Okay, so that's the cats. So if you want to, just put a line through like wives and sacks and cats.
Okay, so over here, right here, we figured this out. So put a check mark next to the first line here, and put a check mark next to the second line. And we're figuring out this third line with that, so let's put a check mark there. So let's figure out 7 to the third. We know 7 to 7 is 49.
So then
And now let's go
49
49 times 7.
$343.
Okay, so next, what do you think the next line's going to be? If we have 7 to the first, 7 to the second. Oh, we need 343. Don't erase 343.
All right. 343.
Because that's going to be,
The 7 to the third, that's going to be the cats.
right.
Number of cats.
Now we got to do the kittens, right?
Uh-huh.
So we have 7 to the first, 7 to the second, 7 to the third. What do you think we're going to do next?
7 to the fourth.
Okay.
So 343 times 7.
So think about this. We have 7 times 7, which is 49.
Uh-huh.
7 times 7,
Just 4.
well, it's 40, but we have 343, but we can multiply that by 7. That
And I'm
would
going to
probably
tell you
be
that's
easier.
2,401.
Okay,
2401.
2401. So let's put a check mark on the next one. So now, what are we going to do? 7 to the,
7 to
You're
the
through
fifth.
now, right? Because it says kids, cats, sacks, and wives. How many were going to St. Ives?
we're done.
Oh,
So
yeah,
what are
yeah.
we going to do with all those numbers?
Add them.
Okay, so let's add them all up. You could rearrange it if you need to put them in
Here, you know what?
order.
Do it easier. Use a calculator.
Oh, he's letting me use the calculator. Yes. So what are you adding up? What numbers?
So 49 plus 7 equals 56 plus 343 equals 399, and then plus 2,401 equals 2,800.
What are we forgetting at the very top? Did
The
you?
1.
There you go.
All right, so write it all down. How many you've got all together?
2,801.
Now, I have a simple question to ask you. Let's take a look at the riddle again. As I was going to St. Ives, I met a man with 7 wives. The 7 wives had 7 sacks. The 7 sacks had 7 cats. The 7 cats had 7 kids. Kids, cats, sacks, and wives. How many were going to St. Ives?
2,801.
Read the first line for me.
Oh, wait.
2,802.
Well, hold on. Just read it for me. Just read the first line.
As I was going to St. Ives.
So who was going to St. Ives?
A person.
Did it say anything about the other people going?
Oh.
It just means he met them, right? Does that make sense to you now?
There's
He only
one.
met them.
There's only one going to St. Ives.
Oh.
Oh, now she's got, there you go. All right. You know what?
He
For some
does it
great
all
work
the
today,
time.
you got yourself a meal courtesy of our friends at Broken Yoke. So congratulations on that. Areen, you certainly did learn some today. Did you have fun today?
Yes.
There you go. That's the key right there. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary STROOPE Family Foundation, Panama-Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.